Hey guys, we're back with another video. Wanted to do an update. I don't want to do an update on the motion sim until I had it painted and looking a lot better, but that's still going to be a little ways off. So wanted to do an update with what I've done currently. So the motion sim is currently set up in its flight mode. I've got all of my Honeycomb flight setup on there. Got the Alpha, Bravo, and I just purchased the Charlie rudder pedals. They're already a little bit dirty being out here, but nothing that a nice little wipe down wouldn't fix. Those are upgraded from my CH Products rudder pedals that I've had for the longest time. I like these a lot. They're very, very decent rudder pedals. Haven't had a ton of time with them, but just the fact that they're so much more spaced out than the CH Products, it's exactly what I needed. The CH Products were just too tight, and the way that I wanted to have the center shaft, the center stick, sorry, in there meant that I needed that to be a lot wider in order for it to feel comfortable. So just went ahead and purchased those, and they fit just about perfectly inside of there. They're the exact width that they needed to be. Basically, they couldn't be any bigger, which is one of the reasons why I went with these instead of any of the other high-end rudder pedals. They're just too wide to fit inside my sim, and I didn't want to modify the entire footwell more than I already did. Actually, if we, let's see if I can take this out. Oh, you're so heavy. Okay. Okay, gotta use two hands. I know this sucks for filming, but it's gotta get out of the way so I can show you. Okay, so the last time I showed you the footwell, it had a bunch of spare aluminum parts from outdoor furniture, and it wasn't flat, it wasn't in there very well, so I just cut it out and completely rebuilt it out of just tube stock aluminum. So now it is nice and flat. I did have over here, I had this set up, and you can see the weld down there, and there's actually a bit of weld over there, and that's because I did have a dead pedal. That piece actually right here was sitting in here like that, and it was a dead pedal for the clutch. That's the mounting point for the Fanatec pedals when, you know, it's in the driving mode. So I had the dead pedal set up there so you could rest your foot on that when you weren't using the clutch. But when I got this big boy, it came in, it's so wide that I had to remove the dead pedal, which sucks, but just having that bar there is enough to rest your foot on. And I'm also contemplating just getting diamond plate. Just getting a big piece of diamond plate and cut it to fit down there, but I'm not sold on that idea yet. That's more money and more work. So that is one of the first things I redid, is rebuilt the footwell. So now that sits in there nice and flat. I might have to modify or create stops in there, because this does slide a little bit. Just because it doesn't have, it just has like the rubber feet on it, and I don't have any hard stops on there yet, but it doesn't move enough to actually be annoying in the flight sim, so I haven't done that yet with it. Let's see, the next thing, I'm not sure if I mentioned before, but I have the wind sim all wired up and running. I know I've mentioned in pretty much every video that I keep meaning to do that, but it's now completely wired up, wired into the plugs, and then down there, if you look at that red guy right there, that Monster Moto, I flick that switch, then that's power for it. Turn it off and drop the power. So that's been wired up. I just didn't actually wire up the fans, but this here is the fans. This is the main emergency stop switch. It's the main power switch to turn on the motion sim. And then this one is wired up to 24 volt, or sorry, the 12 volt lights. When I used to have the big giant cage that was all on here, I had the lights set up on there, and so that was wired up to this switch here, which I'm probably going to remove from there and reinstall on here. I just don't know how or when, and I won't do that until after I paint and everything. So fans are all wired up and working. Then the next thing I did was I got this guy mounted here, and this is for motion compensation, which hasn't been super high on my list of priorities as of yet. But that's just because my motion sim previously didn't move that much, and it doesn't, for some reason, in Assetto Corsa, you don't notice it so much. Like, none of the driving games, you don't notice the surge. Like, you don't go through the dash and through the seat very much unless you're drifting and doing like a big pitch while you're braking or something. Then you'll go through the seat. So I haven't needed that so much until I got into Flight Sim 2024, and with this motion simulator, the roll on this is so much. The roll and the pitch actually are just so much that you know, if you roll the aircraft along with doing yaw and doing the traction loss, it will basically just like throw you outside of the window of the aircraft. And then same if you roll this way, you're rolling into your co-pilot's lap, and it's just not very good. It's very immersion breaking, and so I got that set up. I first had this zip tied onto the fan, and I just had the rear little the wrist wrapped around the back one here, and it was good. It held it on there. The problem is that these guys, it doesn't look like it, but they actually have a ton of flex on them. And when you're in the rig, any sort of flex on this thing is detected by the headset. The camera's on the headset. So basically, this thing was shaking a bunch while moving, especially during big moves, because this thing, like if you can look at the bottom of the mount, it just moves because it's just plastic and it's not that solid. It's not meant to be a super solid mounting point. So just had this aluminum bar, welded it down there on the mount. I did a really crappy job on this one because I thought I turned the argon on, but apparently I did not, and I was using like 3 cubic feet per minute while welding. So, but it's strong enough, and if it starts wobbling or has any sort of effect, then I'll just, you know, hit it again, but actually use argon this time, which is a good idea. So got the Fanatec wheel over here, and I could have used the T-slots and just bottom mounted it with the T-slots, but if I did that, then it would have come off of the wheel hoop straight out, and especially for taller people, it just, the wrist position, it would kill your wrist. It would be very non-ergonomic to hold it in that. So I knew I had to tilt the wheel up, plus I wanted it to feel somewhat how the T300 RS felt. So I just basically modeled that mount off of the same angle that I got when the T300 was mounted flat on here, because the T300 mounts flat and then the shaft comes up at an angle because it's meant to be mounted to desks and stuff that's lower than your actual arms are, so it's mounted at an angle. So I built this mount off of that, but I needed the mount to be removable, so that way I could, you know, put on the yoke whenever I'm flying in the flight sim and I want to do like flying the Cessna or whatever. It actually has a yoke, and so flying with the center stick always just felt weird. So I wanted to, plus I've never really used the yoke very much, so I wanted to start using that more. So I needed to make sure that those were interchangeable. So I had to build the mount to where it just bolts on with 4 separate positions. And underneath here, I just ran 2 bars that go all the way down. You can see the holes for the side mounts, and then the other holes are there. So that's where these two bolts go in the side holes, and then these two go in the holes underneath. And that bolts on, it's all nice and secured. The 300 mil rim, the 8 Newton meters, the Fanatec stuff is amazing. I got the shifter set up and mounted over here. I actually, when I mounted it, I moved it a lot more inboard, which I'm thinking I might need to change. And the major reason for that is, let's see if we can move this back in position one-handed. Okay, it's a lot easier going down than it is up. So the major problem I have now, I've noticed this, especially, I don't notice it because I'm like 6 foot, 6'1", so my driving position is like around there-ish. So, you know, the seat, especially with it kicked back so far on the rails, like that's a pretty far back seating position. But when my nephew came over, he's a bit shorter, and so he had to move it forward, and I noticed that you can't move the seat all the way forward on its rails because this part of the seat is hitting the shifter. So I would have to move the shifter, you know, an inch or two in that way, which I can do. I would just have to cut this, remount it onto here, and then just re-weld it over here and actually get on there. And then I'd have to drill new holes for the plate, and it'd be a bit of work and a bit of pain in the butt, because especially because this the steel plate is held on to this aluminum bar with just one bolt right here, and that's the bolt that's going up into the bottom of the shifter. If I move the shifter over, then this bolt won't have anything to go into, so then I would need to have like a super thin bolt head that then goes down, but it's not going to be thin enough to, like, it'll still teeter-totter. So I don't know, I'm not super excited about solving that issue right now. Okay, so now I guess that just moves us on to all the issues. Again, the pedals basically use the same mounting brackets that I use for the T300. I just had to space them out wider and move this bar up. Basically, I believe the bar was down here and it was facing the other direction to mount the T300 pedals, so I just had to move it up and then put it to where the tabs were down, and then modify the holes a little bit. That was no problem, easy peasy. I did have to put this, I had to weld this bar stock onto the front. This is what the brake pedal rests up against, and since I have the load cell, I didn't want any give. Like, I couldn't just use these little tabs because they'll flex. So welded this guy on, and there's no give whatsoever in the brake pedal. That works perfectly fine. So I'm not sure if I showed this, but I got the acrylic done for the top of the box. So now any liquid that's spilt on the top, you know, will just kind of pull up there. It won't run in. And more importantly, any metal shavings from grinding or whatever I do over here on the bench won't get inside of the IBT2s and arc and bridge stuff that it shouldn't. So I've got that on there. Just recently rained, so I had to wipe off some of the dew that had collected up here. It didn't actually rain on this, just, you know, a little bit of dew collected on there, so wipe that off. But over the last several weeks, I've been running the sim, and it's been fine, except for the last week. In the last week, I've probably blown 6 IBT2s. I basically blown all of the surge motors, or the surge motor drivers, 3 times. So there's 2 in there that are running parallel with double heat sinks on there. And so I've blown both of those 3 times in the past week through I'm still not 100% certain what the issue is, but I think it's just the surge axis is requiring too much power out of those IBT2s, too much continuous draw. So I kind of loosened the trolleys to make sure they were sliding back and forth nice and fine there. Made sure there are no issues on that. And then I've also I found out that the traction loss frame was on a slight decline, right? It was like on a decline like that instead of being flat and level. So it was very easy to move the motion sim backwards, but it was hard to move it forwards. And the more weight that you put in the seat, the harder it would be for that motor on that 7-inch lever arm to drive the rider forward. So I ended up adding a third 2x4 under there, and now with a level on there, it's now more level than it was, definitely. It's not 100% perfect, but it's definitely a lot better than it was. Plus loosening that trolley system so they're not, you know, so tight and squeezed. There's not so much friction in there. Helped it. But, and another thing that I did was I bought heavy-duty caster wheels. I've got one here. I got 4 of them in a pack. I got one here with the wheel removed, and then I was going to replace the swivel joint that was down there, because I thought that the swivel joint was basically the thing that was flexing. I wasn't sure if the bearings were busted in there or if any of the metal was flexing. I wasn't sure. I'm trying to get rid of this sway that you can see is actually quite prominent right now. The main reason is because I took out the wood blocks. The sim doesn't rest on wood blocks anymore. I just set the limits of the motors, so now it'll start up from their complete bottom position, so I don't need the wood blocks anymore. Those little guys. Which, when it was on the wood blocks, it took away a lot of that flex. But that flex is basically not coming from that U-joint. I know it does look like it's moving, but any if it is coming from that U-joint, any flex that U-joint has, that, or not U-joint, but the swivel joint currently has, these heavy-duty caster wheels are also going to have. Because even with no weight on it whatsoever, there's like the tiniest bit of play in this. There's actually more play in this than there is in that joint, because I took this all apart because I was going to replace that swivel joint. When I disassembled everything, I like grabbed a hold of that plate either side and tried to rock that thing back and forth. And I have more leverage on that plate than I do on this, and there was less side-to-side movement in this joint than there was in any of the 4 caster wheels that I got from Amazon. So I decided it's not that plate. It can't be that plate. That's the issue. It can't be that swivel joint that's necessarily the issue. There's 2 things that I've determined are basically my biggest issue. One of them is relatively easy to remedy. The other one's not. One of them is that these, the traction loss wheels, there it is. The traction loss wheels are too inboard, I think. Even though my connection point is out here, I still would like both of those to be wider than the actual frame. That would add stability, so the back end wouldn't want to rock as much. But these are so narrow that you can actually pull one of the wheels up a little bit in an extreme maneuver. It's not a ton, and it's not enough to like worry about it flipping or anything, but I just think that if you pull those out, it would add to the stability. The other problem, I believe, is that the metal for this 4-foot section is just too thin. So I think that it itself is just twisting all the way down. You can see this is rocking. I'm not sure if the material, like this is a real like spongy type rubber. I'm not sure if that not being solid metal and this not being solid metal, I'm not sure if all these things are contributing to it, but this is a nasty wobble that I don't like. But at this point, the only way that I can think to actually completely remedy that is to rebuild this midsection out of a lot thicker, like 1/4 inch sidewall tubing. And I think I can get 2.5 by 2.5. Currently, that's 2 by 3. And it's like just over 3 millimeters thickness. I want to say 2 millimeters. It's like 0.083 inches or something like that. I can't remember. But it's thinner than the 1/8 inch flat bar. Not a ton thinner, but it's thinner than this 1/8 inch flat bar. So if I could get 1/4 inch steel tube, 1/4 inch walled steel tube, kind of something like this. I think that's possibly just 1/8 inch though, but something similar to this. I want to say this is 2 by 2. But I still don't know if that would flex. Yeah. But yeah, possibly rebuilding that center and trying to get any of the flex out of it would be the next desirable step. But as of right now, the kind of back to the motor driver issue, since I've burnt out so many of the IBT2s, and when I do load testing over here on my bench, got this guy bolted in, got a 24 volt power supply, Arduino, and then when I have spare IBT2s set up, they'll be set up over here, and then I will just hang off of this. Once this is powered up, I'll basically just hang all of my weight off of this with a I got a DC power clamp, so I can read the amperage DC that's going to it. And when I have that clamped on to the motor wire with it in there, I've seen it pull upwards of like 37, I want to say. Peak was probably 37, but I could see them easily going continuously like 20, 30. And the IB22s are just not rated for that. And I think that's the problem that I'm running into with those. So I decided to switch up the motor drivers, and I bought 2 Sabertooth 2x32s. So I will be replacing all 8 of those IBT2s with 2 Sabertooth 2x32s. So when those come in, I'm going to get those wired up. I'll get it, wired up on the test bench, make sure it's working, make sure the modified Arduino or SNZ3 code works and it can drive the motor. And then I will put it in there. And then I believe that it should be complete, because it should, with the 32 volt continuous, or 32 amp continuous at 24 volts, that should definitely provide me all the power I need, and hopefully make it to where this thing can run continuously for several hours. Because in this current configuration, I got it to run decent on 12 volt with the 12 volt settings and the IBT2s. It was running pretty good like that. When I switched it to 24 volt, I've had more issues, and getting it to just run continuously has been the biggest pain, basically. But the major difference is when I was running 12 volt, the motors would get hot. Not super hot, like they would destroy the magnets, but the motors will still get warmer than I wanted them to get. Quite warm, let's say. Not hot, but quite warm. With the 24 volt setup, I'm burning motor drivers, yes, which is not good, but they're $5 a piece, so, you know, whatever. Cheap Chinese MIBT2s. But the motors themselves, the surge motor is not getting hot at all, which is crazy, because when it was on 12 volt, it was by far the warmest one. It was getting hot if you ran it for like 40 minutes in Assetto Corsa or whatever. It would be quite warm at that point. So I like the fact that moving to 24 volt means that the motors themselves aren't getting as hot as quickly. So hopefully that means that I can have the longevity there. And if the motor drivers are the only problem, because the IBT2s can't handle those peaks of like maybe 40 volts or whatever, or 40 amps on 24 volt, and that's blowing them up, or it sends them into their overcurrent, shuts them off, you know, whatever. If that's the main problem, then the Sabertooth should take care of that. So once those come in, I'm going to get those wired up. I'm going to get this thing broken down and then grind it all. I have to get all, you know, everything removed, get the fans removed from their mount, remove the controller so I can basically paint everything, paint it black, and then it should be good to go at that point. I think I'm going to start trying to get it out in the public eye more and get more people to test it. I'll, you know, round off all of the hard edges on here and make sure it's, you know, presentable to the public. But that is essentially the next step for the motion sim. Thanks for stopping by.